Okay, so hi everyone. Thank you so much for joining this Ask Me Anything session about Debezium and Google Summer of Code.
Okay, so
Today we are excited to be here with several core members of the Debezium team. We are here to help you with the Google Summer of Code application process and guide you in crafting a strong, effective proposal for the Debezium projects. Before we jump into the Q&A, we'd like to take you a moment to introduce Debezium and give you an overview of this year project ideas. So to kick things off, I'm going to hand it over to Chris, one of the pillars of our team, and he will walk you through what Debezium is all about. Chris, the stage is yours.
thanks, Giovanni. Good morning and hello, everyone. As Giovanni said, my name is Chris Cranford. I'm one of the engineers on the Debezium project over at IBM, formerly at Red Hat. Along with my colleagues, again, we'd like to welcome you to today's Ask Me Anything session. Over the next 30 to 45 minutes, we're going to have a brief overview of GsoC. We'll transition, as Giovanni said, talking about Debezium, looking at the technologies that make up Debezium. We'll discuss change data capture. That is the foundation that everything that Debezium does is based on. And we'll understand why it's important and why it's such a critical piece in modern data-driven architectures. And then we'll cover all of the specific project ideas that we have planned that our mentors are looking forward to working with you on this year. Talk about how to prepare yourself and other things toward the end of the presentation. Whether you are familiar with CDC and streaming, or if this is your first time hearing about it, our goal is for you to leave with a clear picture of what you're going to be building, why it matters, and how we plan to support you every step of the way. So Google Summer of Code is a fantastic opportunity for newcomers to get hands-on experience contributing in real-world open source projects while being supported by the mentors who actively work on that code base every day. It's not just about writing code for the next 12 weeks. It's really more about learning how open source communities operate, how to collaborate with a shared code base, and how to turn an idea into a production quality contribution that benefits real users. The program is designed to be accessible and welcoming to everyone. So whether you're a student or you're simply new to open source, we certainly encourage you to take a look at the eligibility requirements and apply if you are interested. Next slide. Google Summer of Code program follows a well-defined timeline. It's important to understand what phase you're currently in and when that phase ends. Right now, we are in the contributor discussions phase. This is where you have a chance to engage with the project team and mentors, explore project ideas, ask questions, and think about how you plan to shape your proposal. Later this month, you'll have an opportunity to present your proposal to the team for review. Once applicants are accepted toward the end of April, we'll enter into what's called a community bonding period. This is a phase where you get a chance to really get to know your mentors, familiarize yourself even more with the code base if you haven't already, and begin preparing all of the groundwork that for the work that lies ahead that you'll be coding in the following month. During this period, we don't really expect you to do any coding. It's really important about getting your bearings, understanding what the defined goals are going to be for the project, defining deadlines, expectations, etc. As we move into end of May, this is where you're going to begin coding. You won't be working in isolation during this period. Throughout this process, you will have regularly scheduled meetings with your mentors. You'll have deadlines that you'll need to achieve and checkpoints along the way. Remember, the mentorship is a core part of this experience, and you will have consistent guidance and support while gaining experience and exposure through working with open source. Our team is super excited this year to work in Google Summer of Code with you, and our mentors cannot wait to get started. Next slide. Now, change data capture, what is it and why is it important? It is really at a core a system that monitors and captures changes in data so that other software and systems can react to those changes. It's really fundamental to understand this concept because it applies to everything that we do in our project. As we can see here, when inserts, updates, and deletes, these are SQL actions that are being taken in a database, are applied. those are recorded in what's called a transaction log. Some databases may refer to this as a write-ahead log, redo log, or bin log, but just understand that even though different database vendors have different namings, we just generally refer to these as transaction logs. CDC systems like Debezium read these logs and produce structured change events that represent exactly what, for example, a new row being inserted into the orders table, or perhaps somebody updated a price on the order, so there is an update event that represents this. CDC matters for a number of different reasons in modern architectures. It enables things like data synchronization across multiple systems so that they stay consistent without having tightly coupled pipelines. It forms the backbone of event-driven architectures where downstream services can react to changes that happen in the upstream without having to pull for those. It also promotes this whole notion of decoupled systems where producers and consumers don't even know about one another. You also have scalability where you may have one producer that's actually communicating with one or multiple consumers that are interested in that information, or those events, allowing those events to be processed in parallel. And for other sectors and industries, it also provides a solid foundation for auditing and compliance. Since every change is captured, it's immutable, and we have the full context of what changed, when, how, and whom changed those rows in the database, if that information is available. Next slide. Now, Debezium is an implementation of change data capture. It is an open source distributed platform. It is designed to stream real-time changes from the database into event-driven systems by monitoring those transaction logs that we talked about earlier. Now, rather than relying on older legacy techniques like query-based polling or application-level triggers or even database-level triggers to control what generating events when data changes, Debezium goes directly to the transaction log. This provides a number of benefits. It's exactly the same concept that databases themselves use natively for their own replication. It also means that every single row change that happens in your system, we get that information in the exact order that it occurred, and we're able to do this in a way that has minimal overhead on your source system. Now, these change events can then be consumed for a variety of different purposes. If we take a look at the diagram here on the left, we have two source databases, MySQL and Postgres. We have two independent Debezium source connectors. The reason that we need two different source connectors is because each database has their own sets of APIs that we need to integrate with in order to be able to read those transaction logs. But the beauty about this is that even though we have different source connectors, all of them emit events in roughly the same unified structured format. These events are then sent to, in this particular example, in a Kafka ecosystem, they are sent to topics in Apache Kafka, where they can be picked up by downstream consumers, often referred to as sync connectors. These allow you to be able to push that information into target systems, to be able to handle situations like purging of a cache, updating search indexes, or generating derived views and or data in data warehouses, or just simply for data replication. Now, Debezium has a thriving community. We have over 600 contributors, and we integrate with over a dozen different databases, making it the most widely adopted CDC platform in the entire open source ecosystem. So for you as a contributor to GsoC this year, you will gain real-world distributed data infrastructure experience at scale by working with the Debezium project. Next slide. Now, Debezium is not just a single tool. It's an entire ecosystem of multiple components. Now, they are all centered around this notion of CDC. Understanding how all of these components work together is going to be extremely important for you to understand where the project or idea that you might be working on as a part of GsoC, where that fits into the bigger picture. At the foundation are what we call our connectors. These are the oldest and most central part to Debezium. They are the things that are responsible, as we mentioned, for reading those transaction logs and generating those change events. Without the source connectors, there really isn't anything that Debezium would be able to do. These are literally the lifeblood of the project. Sitting beneath these connectors is what we call the engine, or Debezium engine, or embedded engine. This originally came about as a way for us to test our connectors in a Kafka-less environment. But over time, it has grown into a component that we have built other components on top of. Debezium Server, for example, is our flagship standalone CDC solution. We bundle our source connectors with the engine so that change data capture can be used in a very lightweight way in order to be able to sync change events from your source system to a variety of downstream systems. In this case, you are not necessarily going to be streaming to a Kafka ecosystem. You could be streaming to Google PubSub or Apache Pulsar or to Apache Iceberg, for example. There's also, for production deployments, we have a solution built for Kubernetes. Debezium Operator provides the recommended way to manage Debezium Server instances. And on top of that, our Debezium platform offers a friendly UI component to be able to manage and monitor those Debezium Server instances through the operator. Finally, the newest addition to our portfolio is the Quarkus extensions. These round out the portfolio by allowing developers to embed CDC capabilities inside of a Quarkus application. As the architecture diagram here on the right shows, these components are all organized into different layers, and each builds on top of the other in some meaningful way. So hopefully this diagram here on the right gives you a clear mental model of how a new connector or a new feature that you are going to be working on will provide where it fits into the broader system. Next slide. Now, Debezium is built on a robust and modern set of Java technologies that you're going to become intimately familiar with over your time working on the project. Java is our primary language for all of our connectors and core components. So having a strong background in Java is going to be extremely essential with working with our code base. Debezium's most used runtime environment is Kafka Connect. It provides us with a high availability and scalable solution for running both our source and sync connectors. It also provides task management, offset tracking, so connectors, when you stop and restart them, they know where to resume from, and configuration management. So if you are working on a connector or you're working on components that interact with Kafka in some way, having some understanding of Kafka Connect is going to be also important in those spaces. Beyond Kafka deployments, there's also Debezium Server, Debezium Operator, the platform, and extensions. These are all built around Quarkus, which provides a super fast, low memory footprint solution for turning Java applications into native applications. Speaking of the platform and the operator, you also have a chance to work with Helm and the operator patterns that target, I'm sorry.
This is a reminder. Progress report. This is a reminder. Progress report.
My apologies. I thought I put that down, turned that off. The platform and the operator give you a chance to work with Helm and operator patterns that target Kubernetes and OpenShift, giving you exposure to cloud-native deployment practices. And lastly, Debezium's build tool of choice is Maven. For testing, we rely on test containers and JUnit. As a part of working with the project and what your idea that you're going to be working with, this gives you an opportunity to write tests. And these are extremely important to validate that your work performs the way you expect it to, which is extremely valuable when working with real-world engineering practices. Next slide. Now, if you're interested in contributing to Debezium through GsoC, getting started is really straightforward. The first step is to join the official discussion channels for the JBoss community. This is the broader open source ecosystem that Debezium is a part of. Then we ask that you join our Zulip chat, where we have a special channel dedicated to GsoC called community-GsoC. We'd like to ask that you join this channel as well. This is where your mentors and other fellow contributors are going to coordinate, ask questions, and work together throughout this particular process. From there, we do ask that you take a look at our contributing guidelines so that you understand the expectations around things like code style, the pull request workflow, and what the review process would look like. And finally, if you have an opportunity, we do strongly suggest you take an opportunity to find a good first issue in the issue tracker. As we see here on the screenshot on the right, these are explicitly tagged and they're perfect tasks for new contributors. These cover very targeted things like fixing documentation or maybe implementing a few multiple line fix in the code, something that's really targeted and easy for new contributors just to get started. Tackling one of these is going to give you immense hands-on experience with our build system, our testing practices, the review cycle, all before you start diving into your proposal later this year. Next slide. So that's a little bit of an overview about Debezium. We're going to transition now, and we're going to talk about the different projects that we have available this year for you in GsoC. Next slide. One of the very first opportunities for you is to work with a vector database called Milvus. Milvus is an open source high performance vector database designed for similarity search across large collections of high dimensional vectors. This is a solution that powers AI and machine learning, such as semantic search, recommendation systems, and others. If you've ever visited Amazon or Walmart.com and you've searched for products, you'll notice that the recommendation system starts showing you things that are similar to what you've searched for. That is exactly what this particular type of semantic search vector database is capable of providing to those web applications. The goal of this project is to be able to build a source connector. It enables, allowing you to enable CDC to get changes out of a Milvus database and stream to downstream systems. A key technical challenge, however, is that Milvus has two different ways that its write-ahead log, that transaction log we talked about, how that is handled through two different versions. So contributors are going to have to investigate and evaluate CDC strategies to approach one or both, depending on how that it gets evaluated and if there are blockers. You will also implement snapshot capabilities for Milvus, and you will also be required to take a look at handling schema management. This is so that if the vector collection structure changes, we can continue to represent the data that we're getting from the events in the right logical representation. The project will offer you a chance to work across multiple technology layers. The internal architecture of Milvus has a coordinator worker node topology. You'll be working with Debezium's common connector framework, Kafka Connect. So it really will give you a full, meaningful exposure to distributed systems, streaming data pipelines, and being able to work in a rapidly growing space of vector databases. And that's all for me. Giovanni, next slide. And I think it's Vincenzo, right?
Yes, thank you, Chris. Thank you, Chris, for the introduction and for the introduction of the Debezium source connector for Milvus. So let's jump to Vincenzo. Go ahead, Vincenzo.
Hi, everyone. Okay, let's talk about the SQLite project. I'd like to briefly introduce SQLite because for those who don't know, it's a small but really powerful database engine used in many scenarios like mobile app, IoT devices, browser, CLI, car infotainment, basically everywhere. SQLite is an embedded relational database engine built around a simple idea to put all database stuff, relations, schema, data, indexes, in a single file. For sure, one of the biggest advantages of is the simplicity, because there is minimal setup. There are no external dependency, no external server processing. Basically, it's self-contained, but also ACID principle based. So it's also robust, consistent, resilient, and so on. With the introduction of write-ahead logging in the recent version of SQLite, adding a connector in the Debezium for sure will extend the support integration to this kind of databases, embedded and lightweight, I mean. But at the same time, it offers a strong learning opportunity to better understand the database internals, how to implement a connector, the CDC design, and all this stuff. So the idea is to provide a source connector able to perform initial snapshot, schema handling, and for sure streaming CDC event from the world files. That's all on my side.
Thank you, Vincenzo. So, okay, so I think now is time for me and Mario. So thank you again. Okay, so, all right, now I'd like to introduce you another project, the Debezium CLI. So the idea of this project is to bring something completely new into the Debezium ecosystem. Today, if users want to create and manage a CDC pipeline, the only place where this is fully possible is within the Debezium platform. With this project, we want to go one step further. We want to build a command line interface, a lightweight, developer-friendly tool that simplifies the entire CDC pipeline experience. The goal is to give users a fast and intuitive way to prepare and build a Debezium server instance, including only the libraries that actually need for their CDC use case, and interact directly with the Debezium platform, which means that you can create, manage, and observe your pipelines right from the CLI. In short, we want to make Debezium more accessible, more scriptable, and easier to integrate into modern development workflows. It's a chance to design a tool that became a natural entry point for anyone starting with CDC. Well, I'm really excited about this project because, as other projects, it's not just a feature, it's a new piece of the Debezium ecosystem, and it's something that could really empower the community, and which create this kind of project means that you will be owner of it, okay? So I think that I leave the word to Mario and the next project, if you don't want to add anything else.
No, it's fine to jump on the next one.
Okay.
So now it's my turn. So welcome again to all aspiring contributors. My name is Mario Vitale. I'm a senior software engineer working on the Debezium core team. So recently, I'm working on the Debezium platform. That is our one of the most recent project. And we build it with the idea to provide to user a platform where the focus is on the pipeline definition and not on the deployment. So you can define how your data moves from the source to the destination while eventually being transformed. So the platform is then in charge to deploy it with the Debezium server. It has also been designed to support multiple deployment environments, but as of now, we only support Kubernetes with our Debezium operator. So the idea of GsoC project is to extend it to provide host-based deployment using Debezium server in a containerized or not way. These also include bare metal machine, virtual machine, cloud services, and whatever we can put on. And the Debezium platform is a Quarkus application, so Java knowledge is required, and also some experience with the REST API, because as you can see on the diagram before, on the slide, this is composed by the two main components. The one that is the stage, that is our front-end application that talks with the backend, that is a Quarkus application that exposes a REST endpoint to manage all the stuff. And you must also be familiar with Docker and SSH. So some experience also with some infrastructure as code tool like Ansible or OpenTofu is nice to have, because this can open also other scenario. So the project is very open. So we have a goal to deploy the pipeline to this bare metal host. And you can propose the way you can do this. So focus on designing the solution and propose a different way to do this. And for any question, don't hesitate to write a question on the chat. So that's all from my side.
Okay, so thank you, Mario. I leave the word to Giri. So Giri, is your turn.
Hello, my name is Jiří Pechanec, and I'm acting as Debezium Tech Lead. I would like to present this this project or this proposal, and let me say that we are looking at the dark side of the force in this case, because this is not about Java, this is about Python. Why Python? Why this proposal? Generally, a lot of computation on data processing is done traditionally in Python and not in Java. So we would like to effectively claim another area of technology. Fortunately, we have already something to build with. There is already available Python module called PyDebezium engine, or PyDBZ engine, that provides an integration, a glue between Python and Debezium. So you can effectively start and run Debezium engine inside Python. So what we would like to do is to take this and move forward to and take a step forward. We want to integrate tightly with Python type system. Right now, we are working just with let's say the raw JSON. So we want to have a schema that is available, and we want to convert it into typed Python Python structures. We want, as you know, AI is quite a hot topic these days. We want to integrate with famous AI frameworks in Python, which are LangChain and LangGraph. So effectively, you would need to investigate and research how to best integrate with these frameworks, how to provide, or more precisely, how to integrate with existing memory store services that are useful with in LangChain and would be useful for AI applications. Also, we would like to have an MCP server that would expose the Debezium data stream to other agents in your agentic application or setup. And of course, last but not least, we definitely need a set of examples that would demonstrate this technology, so the new users would be able to start easily and quickly. And also very important is a high quality documentation, because what is not documented doesn't exist. So just a short warning, I myself, I'm not Python expert. Fortunately, my colleague Vojta is definitely way better in that regard. It doesn't mean that I don't know Python, but it just means that you will be a little bit more on your own than with Java topics. And that's all from my side. So Giovanni.
Thank you, Giri. Always things super challenging things. So, so we are approaching the last part of the session, and we want to share a few key points about how to prepare a strong application for the Debezium project in Google Summer of Code. An outstanding candidate is someone who actively engages with the community. As already said by Chris, it's really important that you join official communication channel and start talking with us about your ideas, your doubts, and your approach. Introduce yourself, ask a question, and start a public conversation about your proposal. This helps us to understand your motivation and helps you refine your understanding of the project. Another crucial point, honestly, one of the pillars of our selection process is contributions. We need to see that you can actually complete a project. And the best way is to show that is taught your code. Meaningful contribution demonstrate two things, that you can write functional readable code, and as Giri said, you can write also documentation about that. This kind of approach is the right approach for open source contribution. Even small contributions are available as long as they show you are reasoning, you are understanding, and your ability to collaborate. And last but not least, we absolutely want to see a draft of your proposal. You need to open a pull request with a clear and complete strategy for the project. The document should include your roadmap, the goal you want to achieve, the technical detail of your approach, and your reasoning about what is feasible for you. For this, you have all the reference material you need in the Debezium design document repository under the Google Summer Code section. Our selection criteria are mostly qualitative. You have to demonstrate that you can deliver a project with the right level of quality. And quality means you interact with the team, clarify expectation, refine your plan, and define a realistic goal using all the tools you have available, including AI. On this topic, I want to give a moment on this topic. We have received many contributions that were clearly driven by AI. Let me be clear. We are not against AI. We are against no-brain contributors. We want to build a real collaboration with you, where we both learn new things. Google Summer of Code is an opportunity for you to learn, grow, and build something meaningful, not an opportunity to let AI write code or proposal for you. Use AI to help you think, to explore, to clarify, but not to replace your understanding. For example, if you try to talk with ChatGPT or Cloud Code about the Milvus source connector, for sure, he will hallucinate because he will say that it's not possible to create a source connector for Milvus. So we are human, and we are a step forward, the AI. So with that said, I think that we can move on to the Q&A session. Please don't hesitate to ask anything. We'll try to address as many questions as we can. So let me reintroduce all the team. Okay. So let's check the chat if there are some questions. Okay. Okay, let's wait 1 minute. So only to give a moment to someone to have a question. Okay, we have a question maybe. Okay, let me show the question. Okay, so Can a small working prototype in terms of contributions or related to the project can be a criteria for selection for the project? A really interesting question.
I can maybe speak to this a little bit, Giovanni, if you'd like.
Yes.
So we've participated in GsoC in the past, and some of the projects in the past did sort of fall into this use case for a variety of different reasons. So, you know, perhaps something comes up and you aren't able to complete the project in time. Maybe, you know, life happens, right? And so if you can get the project fully along as far as you can, you know, those can be circumstances that we can deal with on a case-by-case basis. But if there is a project and there are specific set guidelines, and you can't meet those for some reason, even though you thought that you might be able to from the outset, just be sure you're working with the mentors and adjusting the scope of the project if need be. Taking Milvus as a great example, it's quite possible that we could get into the weeds of everything and identify, hey, you know, this is not something we can do in 12 weeks. This might need, you know, 12 months, right? So, and in that case, building something that's a prototype or building the foundation for something that someone else can come along and finish is certainly something that we can discuss and figure out what's the best path forward. The other thing I will just add to this as well is also understand that as you are contributing to this as a part of GsoC, once the 12 weeks are over for the project, there's nothing stopping you from continuing working on the feature. So if you don't get the feature complete, if you're working on a prototype and you hit some roadblocks along the way, just because GsoC is over doesn't mean that you can't continue working on that feature and get it to be production quality. So just work with your mentors and try to figure out if you hit any kind of these issues, what is the best path forward. We're most definitely willing to work with folks. So I really wouldn't sweat too much about this and just take it, you know, one step at a time.
Okay, so I don't know if someone wants to add anything else. So, okay, so I think that I can pass to the next question. Meanwhile, Kartik, if you need something else from us, please express in the chat. So let me go to the next question. So for the Milvus source connector, is there a preference between woodpecker wall versus etcd? Do wall limitation like retention or formal stability steer the decision toward one approach? Okay, so I'll try to answer, but I think that Chris is aligned with me. I mean, it's up to you. I mean, if you are able to, I mean, also if you are able to present or to have a solution for the woodpecker, which is the last, I mean, implementation for Milvus, it's super. As I said during the session, it's important that you set some feasible goal, some goal that you think for sure to reach. Okay, so please, you have to reach us if you are interested in this project, and think about studying and start. You have to study the technology and try to understand if you have enough time to complete or to achieve the goals that you think to address. What does it mean? What does it mean? It means that you have to define a proposal with some goals, with some technical detail, but we don't want that you go into the moon. So we want to set some feasible goal, as I said many times. So we know what is achievable in that time, what is achievable with your knowledge. So to give you an answer, reach us and we should talk about what we can do together. Okay, so let me go with the next question. I think this one is for Giri.
Yeah, that's for me. And there is also one more. So one question down. So I think I will answer both at the same in the same
Okay.
turn. So the first
Okay.
thing, what are the use cases intended? Well, the answer is how to say it, a bit not exactly unclear, but very open. This is a really greenfield project, and we and so effectively, I would say uh, the use case is the development and enablement of data from relationship data from relation databases uh, in AI pipelines and in AI agents. I know that's a bit vague, but I would say that the clearer definition and goals uh, um, will appear during the research phase of the project. And with regard to the good first issues, uh, unfortunately, that's you touched a bit of pain point because right now it's really the first attempt for the Python, so we don't have good first issues defined. But what I would like to recommend you is not to contribute directly to Debezium code base, but develop some examples and contribute to the Debezium examples repository that would show Debezium used with Python. For example, today I created a PR that shows usage of Debezium inside Jupyter Notebook. So what you can do is that you can take a look uh, uh, for other examples we have for Java for simple Java web applications that shows the usage of Debezium in Java web applications, and you might develop some easy Python web application that would show the usage of Debezium inside Python. That's the way I would recommend you to follow right now, with as we don't have the first issues as I said.
Yeah, I want to add something about that. We don't want that you maintain things. We want to create things. So this is something new for you. It's something new for us. So it's a really good opportunity to create a new piece of work. So, okay, so let's go to the next question. Okay. So, can raising issue while investigating particular file for another issue will be considered a good criteria, which can also be posted in the making of proposal?
Maybe can I try to answer
Okay,
each one?
thank you.
Yeah, generally in the open source, I think that every small contribution is welcome when they have some quality inside. So if you, while navigating the code base or looking through the project, playing with it, you find a potential issue, we're going to open an issue. If you provide some meaningful information, this can help also us to investigate and maybe solve the issue. So in general, this is a good practice. I'm not sure if this can be also posted in making of the proposal. Maybe it's just a cool print of what you did together with the PR and documentation, the things that you did. Maybe you can put on your proposal to show what you did on the project.
Also, if I may add, there were, I think, 2 or 3 instances where effectively, as some of you were trying to contribute to the issues, as a part of the investigation, you identified that the issue is no longer valid because it was fixed uh, by something else in the past, but still the time and effort you dedicated to it, it's valuable to us because you are helping the project and you helped to clear the backlog of the issues we do have. So even this is contribution.
Okay, I think that we can go to the next question. I don't get the question, so I'll publish it, but I don't. So it's someone of you. We have issue in Debezium using as log-based desyncing.
I would ask
Okay.
whoever asked this question to, if you could just post the question with a little bit more clarity, we can come back to it.
Yeah,
It's
exactly.
a little bit vague for us to be able to understand what you're asking.
I agree. So next. So for the SQLite Debezium connector, what level of wall parsing is expected for this implementation? Should the connector interpret the wall at the page level and extract the raw changes? Well, is another smart question, and I answer with a smart question. You have to propose it in your proposal. So you have to start again. You have to see what is feasible for you, and defining also a roadmap, and also all the trade-off on a solution. So you are aligned. You are aligned. You are. I mean, it's okay. And yes, please prepare a proposal. Prepare some stuff related to that, especially as I said, the trade-offs. Because I mean, mostly we can achieve everything, okay? But the most important thing is to understand what is feasible in the time that you can work on. So. I think that I mean the other questions is the same. So technical detail we can discuss it in during. I think that going on the technical details is better to go on the Zulip. Okay, so to have some place in which you can also we can help you in the best way on the question, but I mean, maybe for this question I can answer about the SQLite hooks to produce row-level events. We prefer a solution based on the wall, for sure. Okay, if I can give you a very quick answer, but you are making me in a difficult position, because we have to study together the best approach for this project. Okay, so let me show the next comment. When huge data changed from the source, processing are no tool to monitor the sync process issue. Log reading is very difficult.
I guess that relates to the question above we weren't able to answer.
Yeah, and they mentioned below also syncing source and target databases. I mean, I guess it really depends on, you know, where is the source connector at the moment in time? Where's the concern? Is it in the streaming phase? Is it in the snapshot phase? If it's in the snapshot phase, the log, or if you've enabled notifications, are really good ways of being able to know if you where the snapshot happens to be in the progress. You can also have JMX metrics with an observability stack that's going to benefit you both on snapshotting while also streaming. So while Debezium doesn't provide you those things out of the box in the sense of we don't give you a full observability stack, we do give you the tools to be able to plug in an observability stack to be able to see what's going on in the connectors. So I think here, while I can agree that in some instances, CDC can appear difficult on the surface, it's all a matter of just making sure you have all the right tools and using all the things that are at your fingertips to be able to debug, isolate, and understand what is the root cause of the problem. And once you know this, then you can start looking at what you need to tune and tweak, whether it's configuration, infrastructure related, to being able to make that process more efficient.
I don't know if someone else wants to add anything. Okay, I'll go to the next. So we are approaching the end of the session. So, okay, maybe this one is for me and Mario. For the Debezium CLI project, as it is a new feature, yes, so that it means that a new repo will be made in the Debezium GitHub. Do you want to answer, Mario? Or,
maybe I think it's irrelevant. Maybe yes, maybe not. It depends, but it's not the core of the problem here. So
yeah, exactly.
we will discuss together if there will be.
I would call this implementation detail.
Yeah.
Exactly, implementation detail. Yeah. Thinking, okay, this one is again, okay, another question. When going through the repos, I always wonder when adding a new connector to the Debezium, what key architectural aspects should contributors consider? Early offset, snapshotting strategy, and schema.
One of the common things that at least the community-led connectors tend to do is they focus primarily on the CDC aspect first. So making sure that you're at least able to collect the schemas so that you can generate the events correctly, and then focusing on the CDC aspects. Once you have that component done, usually they will come back in and they'll focus on snapshotting and other things. But you can certainly go the other way. It really depends on what is easiest for you and the path that you want to take. There is no right or wrong answer on how you want to approach implementing a new connector, which features you want to implement first versus second.
Yeah. On the other hand, I would say the streaming part is usually the hardest. So
yeah, I was thinking the same.
and snapshotting is just then only piece of cake. So I personally would follow that road and focus on the streaming first, because in case you will run out of time, you will do the heavy lifting, and the connector can be then completed relatively easily. While if you start with the easy part and the most important, the core, the streaming is not finished, then the usefulness of the contribution is a bit more limited than if it's other way around.
Okay, so I'll go next. For the Debezium CLI project, what are the till now repository present in Debezium GitHub which are somehow connected or related to the CLI idea? Well, I mean, in the past months, I worked on the JBang integration for the Quarkus extension. So giving a look to this stuff, this work, maybe can help you understand what are the things that or technology in which we want to do this project.
And I believe the Debezium platform is
Yeah.
definitely good.
Exactly.
Yeah,
Also,
I can add,
for sure. For sure. Let's go next. Interesting. Maybe we can also introduce Indra in the chat.
So for the pipeline, we already have an overview, but down the line, I'm not sure if this is a Q2 or Q4. We are also going to add the monitoring feature, so you will have more stuff on the overview page from what we currently offer.
Okay, cool. I don't know if Mario wants also to add something or Giri.
No, I'm okay with the answer. Just to highlight that we don't have an explicit project for GSOC about the UI part, because the stuff related to the platform is more involved on the backend part. So
yeah,
I don't know if this is the point of the question, but
yeah. I want also to underline, and Chris can confirm, you can also propose things that are a bit outside our project, okay? Our project are some guidelines, and you can see that are all green fields mostly. So if you think that you want to do something related to the UI, please propose, please reach the Debezium core contributor like Indra, and we will try to understand if it's something feasible or not.
yeah.
Okay. So just wanted to check for Google Summer of Code 2026, is it a single student assigned to a single project in the Debezium? The answer is yes. One single project for one single student for project. So if someone wants to add something, but
yeah, I just want to add though, Giovanni, even though it's one student, you have two mentors for each of these projects.
Exactly.
So there should be always someone, if you have questions, that you can reach out to, whether we do this so that there's coverage if we're on vacation or whatnot, that, you know, at least we aren't putting any sort of blockers in your way to completing your work. So there is one student, but you do have multiple mentors.
Cool. Maybe we are approaching the end. This is maybe the last question. For the Mirrorless connector proposal, should we mention design trade-offs, or is that necessary for a prototype?
I would say this is something that's really important when you are putting your proposals together, because as you are trying to present to us your reasonings for why you want to go one particular way versus another, identifying those trade-offs, identifying the advantages and disadvantages of one versus the other, it really gives us an idea of being able to see what your thought process is like, and to understand your reasoning. If it's well described and well thought out, it can also cut out having some long conversations about trying to understand your reasonings, right? So anything that you can do up front as a part of the proposal to clearly articulate the reasons why you're taking a particular path is only beneficial for everybody. And it really shows that you're putting thought and effort into evaluating all the different possibilities.
On the other hand, if you will present, let's say, multiple choices, and you will choose one, and we, for whatever reason, decide that it's not the right one, that it was not that because there was something behind you didn't know about, that's something that doesn't disqualify your submission or whatsoever. Yeah, it's just then we would just talk together and would recommend to use different approach as the final solution. But the most important part is to have the choices, and then we can together decide what's the best alternative. You can propose one of them. Why do you think is the best one? And we can just say, okay, that's fine. Or maybe we can say, you forgot about this or that, and please think about it once again.
Okay, so let's go maybe to the last question. While making the proposal for the Debezium CLI project, what all need to be covered other than the implementation detail? I'll try to answer. As I said during the session, there is the template, and in the template and also in the README, in the Google Summer of Code section of the design document repository, there are all the necessary things that you have to write. Also, you have to write for sure a roadmap. It's really important, the roadmap, with all the deliverable that you want to that you will reach during the weeks of work. And it's important also to mention your contribution, your idea. So you will find all this kind of information inside this repository. Okay, I think that we have answered all the questions. Yes, I think yes. So So thank you very much for all of you to be here, to mentors, to contributors, to candidates. So let's see into Zulip chat, and please try to create some contribution without using too much AI. Only the right amount. So okay. That's all, guys. Bye.
Thank you.
Thank you, guys.
Bye.
Thank you.
Bye.
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 Bye.